You can see here the headquarters. Marposs was founded in 1952 in Italy, close to Bologna and at Bologna. The next picture is where I'm located. This is in Erkra, Germany, close to Düsseldorf. So Joachim was founded in 1977 and was the first company who started with process monitoring. And the aim of process monitoring in the past was not to detect small failures like scrap marks or like other things. The first aim from the customer needs was that we want to mount, or the customers asked us to mount sensors on forming machines to stop the machine in the night shift if there is some issues. That we stop the machine to protect the tool and the machine. That was the beginning of process monitoring. And the next picture is the headquarters of Marposs India. So Marposs India has overall 6 offices, roughly 150 people are working for Marposs India, mainly in sales, service and application. Yeah, what are we doing GmbH? So the GmbH is well known for the process monitoring. In the presentation before, we hear a lot of simulation, and what we are doing is we measure this simulation. So for the forming industry, we have also cooperation with simulation companies so that we can load the simulated curves into our unit so that the customers compare the simulation curves with the reality. In stamping and forming, the main aspects are tool and die protection, machine protection, so overload protection. I think most of you know this, overload protection for machines. Also, we can give a setup to the operator. That means the operator sees directly if the process is stable and if the setup of the machine is in a correct way. Also, we have the data management, because in the last 10 years, driven by Industry 4.0, everyone wants to share data, wants to grab the data, so we can send information to the ERP system, to MES software. We can collect also the process data and store and analyze later on. So therefore this topic is coming more and more interesting for the customers, and so we have interfaces like OPC-UA and QTT to exchange with the customers information. Yeah, the main markets, of course, where we are is one of the main markets is automotive industry. So all safety relevant parts in Europe mainly are monitored. So sometimes the automotive industry is driving our customers to monitor the parts so that they can sort out the bad parts directly and stop the process and maybe check out the tooling and see if something is going wrong in the machine. Of course, the connector industry, you can imagine if the machines are running like 500, 700, 1,000 strokes, more failures can appear, that's for sure. If you're running the process very slow, nothing happens, but these machines are running very fast, so therefore, for example, slugs can come up and cause slug marks. Other products like the cylinder head gaskets is one of our main customers using this. So every cylinder head gasket that is produced is monitored with sensors because we want to avoid even small slug marks, because then it's a bad part. We have electronic industry very similar to the connector industry, and then of course another wide field is the metal packaging. One example is that we can monitor the easy open end for a can. Everyone uses a can, so we can monitor the clinching operation so that we can detect even if there's a small crack inside this, and then we can directly sort out these parts. What kinds of machines can we monitor? There's a huge range of different machines. Automatic punching presses, high-speed presses, coining machines, drawing presses, fine blading. You see, it's a wide range of machines that we have. And depending on the machine type, there are different approaches from the customer. If you have a large transfer press, of course, you have more issues with, for example, splits or cracked parts, because you have usually drawing operations of the big automotive parts. If you have the high-speed presses, it's more slug detection because you have very thin material and fine parts. The machines are running very fast. So it depends on the machine what kind of application we can offer to our customers. Yeah, what influences the stamping process in your plant? Of course, the raw material, we hear in the presentation before, the influence of the material. Yeah, of course, the supplier it's not. So therefore, we have influence by the material. We have influence by the feeding. Yeah? So therefore, the feeding monitoring in stamping is mandatory to protect your tooling. Yeah? Then we have the lubrication. Sometimes it's more or less, maybe the oil is different, lubrication is different, so it also infects your process. Then the tooling, the tool wear, the condition of the tool, the setup of the tooling, all these things influencing your end product. And then of course the machine itself, if the machine is in a proper way, if it's good maintenance, or maybe if the bearings are a little bit old or not good anymore, so therefore it could also influence this process. The environment, so with our piezo sensors, it's a difference if the machine is cold and you start the machine in the morning, or after 30 minutes when the machine is warm. We can see this is an impact of the force that is inside the tool. And of course the human factor, depending on the operator, maybe the machine setup is in a proper way, or maybe the machine up is not in a proper way, we can see this. We're very complex tools, so not every operator can handle it very good in a good way, so therefore the setup of the machine and the tooling is at the end by the operator. And what we do is we just monitor in process what's happening when the punch is going down, the stripper plate is going down, and we select these forces and try to find out if something is going on. And the basic principle is like this: we can mount different kind of sensors on the machine, and what happens when the machine is going up and down, we receive a force signal. And in the next step, automatically the system put an envelope curve with an upper and lower limit automatically around this. So we are comparing one punch after each other. So after the teach-in, which is usually half the stroke time, for example, if the machine is running 100 strokes, 40, 50 strokes we use for a setup, and then automatically we put the envelope curves and the operator has to do nothing. And if something unexpected happened, could be a crack, could be a slug, could be a punch breakage, then the force is going out of the limit and we can stop the machine. For the stamping machines, usually we stop the machines. If you have a sorting gate, we can of course sort out these parts. The sensor positions depending on what kind of failure we want to detect. Of course, if you have small slug marks or scrap marks, we are not able to detect them with a frame sensor. We have to go close to the process. But for example, for the general monitoring, the frame sensors or the conrod sensors are good enough. If you want to go deeper, you have to mount the sensors behind the punches or in the stripper plate. You have to glue them. We have different kind of sensors for all these applications. Maybe you have to drill a hole, maybe you have to make a pocket where we can glue the sensors. And in the next picture you will see the difference between the sensors that are far away from the process. You can see here they can cover a bigger part of the tooling, and if you go closer to the process then you have really precise, detailed information about a small area. Here's one example for the sensors in the RAM. That means it is an overall force of half of the tool, for example. And if you go going closer to the process, then you have the signal for blanking. You have the signal for your drawing operation. And you can see that those signals look different. You have a different signal for the piercing operation and for the trimming operation. So as you can see, depending on the application, if we have a drawing operation, we want to detect the splits or the cracks. Of course, we go into the drawing punch, and then we will have a different signal as we want to, for example, detect scrap marks, and we go into the stripper plate. The setup of the machine, we can store, if the operator is producing good parts, he can store this article, and then we have a reference curve for each channel that we monitor, for each sensor. So the next time the tool is coming again in the machine, he can load those information, and then he can see the reference curve and the actual curve. So therefore, here it's close to the original one, with the next setup of the machine is better, and then the operator can say, okay, now it's a 100% match to the last time where I produced good parts. and then the operator can start the job. Another key point is that we hear before energy consumption. One problem is, for example, that some of our customers are driving too far and then driving in the stop blocks, and you have too much energy that you don't use. So the green curve, for example, is only the force you need to produce good parts. And the red curve is only because you're driving too much on the stop blocks. And if the operator detects this at the beginning, he can change the setup of the machine, and after a while he has the perfect signal, and then you have lower energy consumption to produce the part in a good way. And also the speed adjustments. If you have the signal, and if you can see that the quality factor is good enough so that your signal is stable, you can run the machine faster and faster. Maybe this is too fast, you see that the signal now is changing, so the operator can reduce the speed, and he can find out what is the optimized speed for the product where I have a stable signal and I can produce a part in a proper way. So here are some examples to understand what kind of failures we can detect. You see the scrap mark, it always looks like, okay, it's just one scrap mark, but if you produce here like 6,000, 10,000 parts and they go into the customers, maybe they go into some injection machines and then they are built in a car or whatever, it's very extremely expensive to bring all those parts back. And we have some cases in the connector industry where they have customer complaints and they need to bring back like 10,000 parts. It can cost millions. This is the principle of the slug detections. So usually we go into the stripper plate, we glue a sensor, so the customer, the tool department, they prepare pockets in the top of the stripper plate. Then we are gluing the sensors inside those pockets, we run out the cables so that the operator can easily connect those cables. And if a slug is falling onto the material, with the next punch, we directly detect with the stripper plate that there's some material lying between the sheet metal and the stripper plate, and we immediately stop the machine and can give the operator the information in which section the slug we have detected. And then he can check the tooling, the part, and can produce the part in a proper way. Another problem for our customers, of course, are cracks or splits. Could be very heavy one, or could be smaller splits. So therefore, in this case, you can see here, this is an example, that in that moment when the crack occurs, the force is going down. So you're not able to detect this with the frame monitoring where you just have the high value, so the maximum value of the force, because this will be the same. Also, if we have sensors in the frame, we cannot detect because the force will be the same. So therefore you need the envelope curve, you need to go very close to the process, and with this information you can find out such failures like splits or cracks in materials. And all customers or all producers of drawing parts know these failures, they appear. Another solution is for punch breakage. There we don't have to go close to the process, so we can mount acoustic sensors on the bottom plate or the top plate, depending if I want to have a die crack or I want to detect a punch breakage. And you can see also small punch breakage like this we can detect. And here we are looking into an area. Here's your regular process. Here's 180 degrees. And if you have a punch breakage, it can appear if the press is going up. And in this case, of course, usually no forces can be detected by other sensors. So therefore, if the machine is going up, lifting up, and there's a punch breakage, we can hear the noise through the machine with the acoustic ignition sensor. What kind of sensors do we have? Here are 3 examples. These are ultravision sensors, these are piezo sensors for the slug detections. We have frame sensors and bridge sensors. We have other sensors that we can glue or we can mount them into a hole controls, so there's a huge variation of different kind of sensors for each application. Now we can also customize machine parts and sensorize that we are directly above the punch, so that we really have a single signal of each punch. The general setup of the machine is always the same, because we need to talk to the machine, we need to stop the machine, we need to know if the machine is in running mode or in jog mode. So therefore we have a machine interface that is connected to the machine. We have the monitoring unit itself. We need a cycling signal, and of course in the best case we have an encoder that we know exactly which degree we are. And then we are able to to connect a couple of sensors. Could be piezo sensors, it could be distance sensors. So for example, if you're working with distance sensors for the slug detection, you can also connect them to our system with the envelope curve and you can monitor it. Also the digital sensors for the feed control, we can connect up to 16, 24 sensors depending on the model. This is the general information that the operator has. You can see it's very easy to handle. They can press a setup button, then automatically the curves are. We have maximum values, we have trending forces, and we have a variation of different counters. This is one of the units that we have. It depends how many units, how many sensors you want to connect. We have units up to 8 sensors and other units up to 24 sensors. Yeah, the benefits I explained at the beginning is to reduce tool and machine damage. Less customer complaints regarding failure parts, we have a faster setup time, and we can find the optimized speed. Of course, it's a big topic in Europe, multi-machine, one operator is handling 2, 3, 4 machines depending on the company, so therefore it's always good to have this protection. Do you know if something happened, we directly shut down the machine and the operator can then go to the machine and check what's going on. So now coming to the next topic of the process data, digitization. So of course we can connect all those units to a server, to your server, and you can sit in the office and you have the same view like the operator. So if you have a supervisor in the company that takes care of this information, he can sit in the office, he can check if the envelope curve setup is okay, and he can directly check, and you don't have to run through the plan and go to machine to machine to machine. He can sit in the office and have the information. We can store all failures automatically, so that, for example, if you're in the morning, you can check in the night shift what happens. Do I have some stops? What kind of failures? We can see directly the curves. Of course, you can maybe delete these after 6 months, because if you don't receive a customer complaint, you don't need to store those data. And then if you want to go more into detail, like long-term trend, you can store the exact curves and see the behavior of the tool wear. You can see the reaction of the machine after a tool change. You can see the reaction after a coil change, maybe if you have different suppliers. So that is something that you can automatically, we can store this, and all these features are available for you if you have installed such monitoring units. Yeah, last but not least, Industry 4.0. So we are always in the middle between the operator machine and the ERP and MES software. So all of our units are directly MES ready. So we have our own software called C-Through, but we are also free to, with OPC-UA, to connect to other third-party systems. So if you have an existing MES software, we can use OPC-UA and send you the counters, the good parts, the bad part, the stop reasons of the machine. So everything is available. Yeah, with the connected world, it means you have connected all machines to the network. We can store the data on our own C-Through server. We are directly in contact with your ERP server, so we receive the information, which job should run on the machine, how many parts should be produced, the speed of the machine, when the job is planned, all this information coming out of the ERP system, and we can forward this to the machine. So we can forward directly to the monitoring unit, for example, that this job should be produced on this machine, or maybe on a machine group. And we have different kind of interfaces. depending on the customer needs. If you have ASP, for example, there's a special interface. Otherwise, usually it's good enough to have transfer tables, file transfer, OPC/OA. If you're connecting those data, then you are able to do much more analysis of your company. So we want to find the weak points of your production. Why is the standstill of the machine? Why is the OEE down? So, and then we have the possibility to have a couple of reports that are already in the system, so you don't have to take care of this. Everything is directly in the software. So that's it from my side. Thank you very much.
Now, any questions? Let us open the questions now. If you have any questions, you can come near the mic and ask the question. You introduce yourself first and ask the question, please.
I'm working as a lead engineer in Scotland, for me. And my note is the problem what we face in the full forming of fasteners, especially in progressive is the wear life of the tool. So the tool generally wears and light deteriorates and it determines the dimension of the part as well. So do you have any solution to determine the to check or monitor the wear, how much has happened to the tool?
So you're working in the code forming, so
Yeah.
you're producing from wire. You're producing code forming parts from wire. Yeah.
From wire to fasteners.
To fasteners, yeah.
Yeah.
So, yeah, usually there we have, if you have a multi-station press, there are sensors behind each station, so the machine makers drill the holes, and with the functionality of the trend, yeah, you can set up a limit, but of course at the end it's the operator decisions, and if we say now that the tool wear, for example, is 10% worse at the beginning, we can stop the machine and then the operator can decide, okay, but I have good parts, so maybe I can set the limit a little bit down and then I can produce another 100,000 parts. Or you can have counters. You can have counters where you say, okay, after 100,000 parts, I want to exchange the punch. I want to do this, and then we can automatically stop the machine and the operator knows now I have to exchange the tool. And with the software, you have the long-term trend, and then you can compare, for example, different tool suppliers, wire suppliers, how long is your tool lifetime? And what sometimes happens is, for example, that the operators are changing the machine because they think that the tool lifetime was too short, yeah? And then next time it's even shorter, for example. So, and this information you can find out with the software where we can store the data, and then you have a long-term trend of this. But at the end, we cannot monitor to the point where we can say, okay, the next punch will be a bad part, so you have to exchange the tool.
Yeah, I think can we do it this way, like between the punch and the die, can we place a photo sensor that will check the dimension of the tool in every stroke, so that will give the current status of this tool's dimension. So if it deteriorates, then it will intimate at what level it deteriorates.
No, so for the diameter, so we have other solutions in the Marposs group, yeah, regarding measurement of diameters or of tooling. So I think that's maybe a topic we can show with our colleagues outside. Yeah, so in our group. Yeah.
Thank you.
Okay.
Okay, thank you. Any more questions? Yes.